We need you tweeting more, Sam. This is super fascinating. Maybe I've just been aloof, but this is super cool stuff.
And so even for the biggest wallets, it's like 30 million people. This isn't a large audience for an app by the sort of conventional app builder standards. And so if you look at that and see like that's the ceiling of your success and you're a serious builder, you might be like, why am I going to build on this platform? I'll go build somewhere else where if I'm successful, there's sort of things can go truly viral and there's no upper bound. And during one of those quests, we hit a milestone where we processed the most transactions that any blockchain has ever processed in a single day, 65 million. And so that made us feel really happy, where it's like, hey, there's all these lab scalability numbers and you can talk a lot about what kind of traffic you can push, but here it's something where it's like, hey, we hit 65 million. That's more than anyone's ever done. We didn't have the gas price go up. We didn't have any increased latency or decreased quality of service. It's just the network working as it's intended to, even in these early times.
Well, Sam, really excited to have you back on the podcast. We chatted a little bit over a year ago. I think it was even prior to your mainnet launch. And a lot has happened since then. So really excited to have you back on the podcast, really deep dive some of the new things that Sui and Mysten Labs have been working on. But excited to nerd out with you once again, because it was truly one of my favorite podcasts that I've ever recorded.
We're going to appreciate the kind words, and really great to be back on here with you. I really appreciate you having me. I can't believe it's been over a year. It feels both like it was yesterday and that it's been 1,000 years. So really excited to pick up the conversation and tell you what's been up with us recently.
Awesome. Well, it's been about 6 months since Sui has officially launched on mainnet. Could you maybe speak to kind of that go-to market, or not even go-to market, but just launch, and kind of your view on the progress since that 6 months?
Yeah, absolutely. So Sui went live on May 3rd. So we had the 6-month anniversary just a couple of days ago on November 3rd. And so launching was really exciting for us, because when we came out of Facebook in late November, or like in late 2021, we could have gone to market immediately with the sort of DM-like tech. And we made the decision, like, we really want to rebuild this thing from the ground up with horizontal scalability in mind, with like this object orientation in mind. And, it's going to be a longer path. We're going to do it. So we were very happy that we were able to get out the door and have the network up and stable and performing well. So it's been going well for the first 6 months. We've had steady growth in active users. We've processed a lot of transactions. We've kept the network up. One of the achievements I was most proud of is we've been running some of these quests that are like highlighting various themes or apps built on Sui. So we've had gaming focused ones. We've had a couple that are focused on DeFi, just to let people see what's out there and to try stuff out. And during one of those quests, we hit a milestone where we processed the most transactions that any blockchain has ever processed in a single day, 65 million. And so that made us feel really happy, where it's like, hey, there's all these lab scalability numbers and you can talk a lot about what kind of traffic you can push, but here it's something where it's like, hey, we hit 65 million. That's more than anyone's ever done. We didn't have the gas price go up. We didn't have any increased latency or decreased quality of service. It's just the network working as it's intended to, even in these early times. So lots and lots more to do. And, it takes a while to bootstrap an ecosystem and get everything going. But I think overall we felt quite positive about the first 6 months, seeing what people have built and just seeing the network coming along.
It is rather remarkable. I don't think that fact is propagated enough, because that is no small feat, combined with having transactions fees stay flat. That's very hard. So congrats to you and to the team. I think that needs to be propagated out into the world more widely.
Yeah, well, this is the not trying to triumph of the Sui Foundation and the Sui core team and the whole community of validator operators who play no small role in making sure that everything stays smooth in these sorts of times either. So it's a community achievement, and we're all quite happy about it. But we want to be doing that on a daily basis, not just doing it once. So that's what we're really looking forward to.
100%. And it's really, I would say, a stepping stone along kind of the journey that we're really all trying to get to, which is ultimately Facebook or meta level scales on blockchains, hundreds of millions and billions of daily active users or daily active addresses. And I think that's just one step in that direction. So again, kudos. But maybe to kind of jumping off where we started last time, nerding out from the tech, talking about how you guys did data propagation, the execution environment. I would love to just re-pick up the conversation and start with some of the things that you have been working on under the hood, or the Mysten Labs team, since you guys launched, or even in the last year since we chatted. Maybe starting with some of the stuff that you're doing around the ZK login, because I think that is one of the hardest parts about onboarding people within crypto, is just making sure that they can have a wallet. So would love to start there.
Yeah, absolutely. Let me start with a little bit of the sort of like background and motivation, and then we'll definitely get deep and nerd out on this bit because I think there's a lot to dig into there. But yeah, like when we decide what new technology to develop on top of Sui or what new features to add, we're really thinking about like growth, app enablement, and product enablement, and all is our primary focus in trying to decide what to do. And so, like one of the key things we ask about is like, okay, let's say a builder comes to Sui and they create some app, and the app is really, really successful. Okay, what's the first thing that could go wrong? Well, the first thing you always hear about is like, oh, the network can't handle the capacity, the gas prices go up or the network goes down, or these sorts of things. That problem we knew about from the start and have the whole architecture to solve. But another one might be, well, everyone who uses the blockchain loves this app, but nobody else is going to try it because it's too hard to become a new blockchain user. And so we think there's like a lot of large barriers to that. Like, to be using a blockchain, you typically have to install this piece of wallet software. It's usually an odd plugin that requires like Chrome super user privileges or whatever. It's like a bit intimidating to install, not the most user friendly, even if the teams do a very good job. And then there's the barrier of, okay, I got to go to an exchange and get some Sui so I can pay for gas and send transactions. And so as a builder, you could build a really compelling experience, but then the ceiling on the success of your app is sort of however many people have installed a wallet. And so even for the biggest wallets, it's like 30 million people. This isn't a large audience for an app by the sort of conventional app builder standards. And so if you look at that and see like that's the ceiling of your success and you're a serious builder, you might be like, why am I going to build on this platform? I'll go build somewhere else where if I'm successful, there's sort of things can go truly viral and there's no upper bound. And so one of the things we've really been focused on solving is how can we remove that install wallet barrier? And this isn't to say that wallets are going to die. Like I think they have a use case and they'll still clearly be there. But I think you can enable a whole new class of use cases if you're able to eliminate the need to do that. Like, what if someone built something cool that using Sui in the background, and then I can send a link to my friend and then they can just try it out, whether they have a wallet installed or, own Sui already or not. And so ZK login, that's really what we were going for, is like, how can we enable a Web 2 like login experience? And so now starting to get into the tech a little bit, what ZK login lets you do is when you go to a login provider, it could be Google, it could be Apple, it could be Twitch. For us, it's anyone who implements this OpenID Connect standard in a certain way. You get back a cryptographic artifact called a JWT, or a JSON Web Token. And the trick that we use is when you make this request, there's some metadata some custom metadata that you can stuff into the JWT. And so we're like, well, what if we put a public key in there? And then so you get back this JWT, the signed attestation that says, okay, I bind your email address to this public key. Now you could submit this directly to the blockchain, and then that would, let you sort of log in with Google. But then like, okay, I've got my Google account linked to a blockchain address. I might not want that. So that's where the ZK part of this comes in, where what we do instead is we have a ZK circuit where it can produce a proof that says, this person has authenticated with this address, and they can sign for this address with this key pair, and then they send both the proof and use the private key corresponding with that public key to the blockchain to send transactions, but there's no linking back to the Web 2 account. And so that's the trick that we use, and then you can build these app experiences. Like we recently rolled out this ZK send thing where you go to a website and you can send links that have Sui or later have NFTs in them. People can click on them and claim them from their email. And that's the sort of thing ZK login enables. And there's a lot of sort of derivative functionality of ZK login that you can do on top of that, but that's sort of the big picture. So I'll pause here for a moment.
That's rather beautiful. Linking kind of your email to the blockchain, but obviously not everybody wants their email linked on a blockchain. So making sure that you can encrypt that or encode that in some privacy aspect with the zero knowledge proof. It's very fascinating. I think maybe on the zero knowledge side, one thing that historically has been a little bit of harder just because the technology is so new is kind of running that transaction. Is that proof just created client side? And does that take a long time to generate?
Yeah, great question. Whenever you ask about zero knowledge, you should always ask about, where's the proof or who's running it? How much does it cost? These are very important questions. So what we have there is the proof is fairly the proof is fairly cheap to generate by these standards. I think it takes a couple of milliseconds. We have a backend service that it's like a validator where like anybody can stand up a prover and run it, or I should say it's more like a full node actually. It's like you can pick up the binary, you can run a prover service for your application, or you can use an RPC provider. Who our RPC providers now are starting to be like, hey, we'll run a full node for you. We'll also run a prover service if you want. It's also in principle possible to do it on the front end side. It's a little bit expensive to do in the browser right now. I think it's sort of like 5 to 10 seconds. I'd have to check the latest folks. So probably like you'd want to use the backend service, but of course, like the crypto team is always looking at optimizing these circuits or like using new libraries that are doing some of the key parts a bit faster.
That's amazing. No, I truly think that is one of the hardest parts, just onboarding people within blockchain and kind of getting them accustomed to Web3, and just onboarding them seems to be the biggest challenge because you have to kind of go to an exchange, you onboard to the exchange, move the money from there to your wallet, and then you can start interacting with applications. And being able to kind of obfuscate some of that steps, or at least go from skip the exchange part directly on chain, like that is a massive leap forward in kind of the entire onboarding experience.
Yeah, absolutely. And so that's one of the other things we've really been focusing on eliminating with a nice native feature. So we also have this sponsored transactions feature built in where if ZK login solves the like conventional SSO like login experience part, sponsored transactions can solve the have to go to an exchange and get Sui part. So there it's very there the recipe is a little bit less mind blowing than the ZK login setup, but it's that in a Sui transaction, you declare what objects you're going to use. Some of those objects are actually get used in the body or the meat of the transaction, if you will. And then some of them are one or more coins that are used to pay for gas. And so the way the sponsored transactions feature works is that the owner of the gas coins doesn't have to be the same as the owner of the other objects. And so what this lets you do is like as a user, I write a transaction that's going to do something, and then I can shop around for a sponsor that's going to do it for me. Or if I'm an app developer, like I run a sponsor service, like maybe it's an onboarding mechanism. I sponsor, the transaction to create an account, or I sponsor, but then make people pay afterward. Or maybe I sponsor everything, and I collect money through a subscription or via some other vector just to hide that friction from folks. So there are these great services like Shinami and the Sui ecosystem that offer sponsorship for people, or like have nice APIs for app builders to use sponsored transactions. And so they can make this part go away. There's also a interesting thing some folks have built that they call dynamic gas, where it's like sometimes maybe you want to pay for gas, but not pay with the Sui token. Well, the platform forces you to pay with Sui tokens, but of course, like there are many pools on chain that let you swap Sui for stable coins, that let you swap Sui for wrap tokens from other chains. And so basically like they'll do a setup where like at the current price, like, their transaction is going to give you a little bit of the coin that they want to pay with, and then they'll give you Sui that they'll use to pay it. And then so effectively you get this experience of paying for Sui with stable coins, your in-game token, or whatever you want. So those things, these two features combined, I think we're really, really excited about in terms of taking away key frictions.
So maybe just to reiterate for the normies on the sponsored transactions, you're saying it's possible not to have like Sui or the native token within, say, like that ZK login wallet, and another account has Sui in it that will vote or allow that pay for that gas cost on the behalf of another wallet.
Yeah, that's exactly right. You never have to have it in that ZK login wallet. And we think this is what their future will look like. Like most of the accounts on Sui or on other chains, like will never have the native token in it, because why would they need it? They're only having objects because they're playing a game, or like, maybe they're trading DeFi with stable coins, or they're doing something else. So you have Sui only if your actual application use case is provided, not just because you have to have it for pay for gas. Then there are these big sponsor entities that, have big pools of Sui, and they can pay for everything on demand. And maybe you have a subscription with them that you swipe a credit card, or doing some more conventional payment mechanism.
We need you tweeting more, Sam. This is super fascinating. Maybe I just been aloof, but this is super cool stuff.
Oh, well, thank you. Yeah, I mean, I think this is a feature that a lot of folks are picking up on other platforms as well. With different levels of native integration. Like, of course, like account abstraction with this paymaster feature is a way that folks are trying to do this in the ETH ecosystem. I think the key thing though is for us, like this is a native feature, so it's really just as simple as like add an extra signature on your transaction and not have to have this indirection of these other smart contracts, or in some cases, like implementing the sponsored feature, like contracts have to opt in to supporting a sponsored transaction, and it looks a little bit different than it does to support a normal transaction. Whereas with this, like at the smart contract layer, you can't even tell whether a transaction is sponsored or not. It just looks the same as any other transaction.
Super fascinating. And then you said the second half of that, I forget what, there was ultimately the sponsoring half, and then you said you could also swap tokens in one transaction. Say if you have USDC, so you could get some Sui if you needed to, if you didn't have any Sui in that account.
Yeah, so this is more of a service level feature that people are providing rather than an application primitive. But the setup might be like you're a user and you've got maybe you're playing a game and you've got a token for their game. And the way the game, and maybe the semantics the game developer wants is that we want app developers to be able to pay for using our game with our token. Okay, well, we're not going to modify Sui just to to accommodate that one game to allow them paying with the game tokens. But if this is a token, it's going to be traded on Dexes, on Deepbook, Sui's native order book, and elsewhere. And so there might be a service provider out there who says, okay, you come to me with this transaction. I see this token. I see what the market price is on the order book. And so like I'll put my Sui on your transaction. I'll sponsor it. And then I'll make sure that that transaction contains a small transfer to my address of this game token. And then after I get it, I'll go and trade it out on the platform. Or maybe the transaction itself just hits the order book directly and gets the Sui and then like pays back the sponsor. And so both of those setups can work, but sort of allows under the hood, it looks or from above, it looks to the customer like they were paying with the game token, but under the hood, you're just using this powerful blockchain primitive of like swap one token type for another to hide this away.
It's beautiful. I really think, my personal belief is we kind of had the like crypto anarchists, like with like early blockchain adoption, like the cypherpunks. We kind of evolved with the ability to do smart contracts, but didn't really have that scalability component. And now we're kind of seeing the third generation blockchain platforms that have the smart contract ability and scalability. And I think within that, a lot of the builders that I've been talking more recently are very ruthlessly pragmatic about like the engineering trade-offs and really making sure that a lot of these things like the Mysten Labs team is building, whether it's the ZK login or sponsored transactions, are abstracted as much as possible, because I think we've tried to go like the normie or like the Web3 route, and it hasn't necessarily translated well to kind of the tens of millions or even hundreds of millions and billions of people that use the web. And as much as possible, we really do need to abstract those while keeping all the properties of decentralization and self-sovereignty or owning your private keys, but just making that super easy.
Yeah, oh, I completely agree. I mean, at its core, to me, like Web3 is about building technology for collaboration. It's about building technology for enabling interoperability, for removing intermediaries, and you can still have all of those things without introducing these UX barriers that I think are really incidental rather than necessary. Like you don't necessarily have to know you don't necessarily have to know your seed phrase to participate in Web3. Like you can log in with ZK login, and it's not like the Web2 provider can send transactions on your behalf. They cannot in the way that ZK login works. And it's also not the case that you have to worry about losing your account. Like you can rely on the Web2 recovery mechanism for that. And if you don't like that, then you can still access the chain with your own seed phrase, with a conventional wallet. It's just about giving people more options to enable more use cases, not being religious about one way to do thing or the other.
100%. And one thing that really struck me from our last podcast that really like I kept with me was one of your comments around kind of like the golden standard for composability. Like your idea was all these assets really live within one ecosystem. It was really breaking down the walls that these Web2 kind of companies provided and being able to natively touch assets. And I thought that was such like a powerful statement, because if you break it down and really think about it, I think that is like the core essence for at least the engineers. Like you remove these individual databases and put everything together. And that's really what makes the Web3 magic. I would love for you just to briefly expand it upon it, because it really stuck with me from the last podcast.
Yeah, definitely. And I appreciate you saying that. Where, I think a blockchain or a platform like Sui, like fundamentally it's a smart contract platform. And what are smart contracts for? Like smart contracts let agents transfer and share objects. Like that's what this whole thing is about. And then so an important sort of corollary of this is that if you put barriers up to sharing or transferring, like you're going to fragment the state across, several different layers, or like shards that become visible to the user or to the validators, then you're sort of getting in the way of that core value proposition. Whereas if everything is in the same place, then you can freely interoperate, you can freely transfer, you can freely share, and none of that stuff gets in the way. So really, like we think of like starting from this very simple thing and trying to just not introduce any barriers at the technical level or at the accessibility level, and in fact, like introducing features that try to break those down as much as possible. And then in terms of like the object part of that statement, like that goes a lot into our object-centric design, where it's like really like objects are front and center in smart contract programming and all the use cases, but you really want to have a representation of this that's super direct to the programmer, that's super direct in the read APIs, that's super direct to clients and wallets. So everyone has this common vocabulary, instead of saying like, well, yes, conceptually you have this thing, but actually like this is represented as an entry in a hash table somewhere, and there are some bytes, and if you want to use it, you have to go like decode it and do something, or like chase a pointer to another hash table. It's like you want to look at it and be like, okay, here's my character object, and then like hanging off of it are its shoes object, and its pants object, and its shirt object. And like when I call the API, I just see I get the thing, I get the object, and then everything that's hanging off of it, I can sort of render it in a coherent way, instead of trying to be like, oh, like here's the protocol for having to understand that. So that's the other big part of this, is just like if this is the fundamental building block, the fundamental vocabulary, then like how do we expose it at the programmability level and then use that abstraction throughout the system, instead of trying to hide it or translate it into different concepts.
And I think a lot of people still, in my mind, don't know that you're the inventor of Move, or kind of led those efforts at Meta, and now kind of took that team and the expertise over to Mysten Labs. I think it's ultimately, I would not be surprised if Move became the predominant programming language in Web3 across like all blockchains in a very short amount of time. But I would love to talk about all the new updates to Move, but maybe just finishing out the topic on kind of like having everything logically centralized. I think one of the big debates that is currently going on and will continue to go on is, to your point, having everything kind of co-located together, where you can kind of like atomically touch these things. And I think it will kind of boil down to inter-validator sharding versus intra-validator sharding. And that still is not a very well-known topic. I think we kind of touched upon it a little bit in the last podcast, but I think as we continue to scale the industry, it's going to be a bigger topic. And honestly, I love the approach that Mysten Labs has taken. So I'd love for you to just expand upon it a little bit more, and then we'll jump into what you've been doing on Move.
Yeah, so this topic is very much related to the so-called like monolithic versus modular debate, where it's sort of like, if you're going to scale a blockchain or a smart contract system, like you're probably going to have more than one machine. And then so when you have new machines, like how do you allocate those? And so like there are two strategies. There's like one is where, okay, a validator can be one machine, or it can be many, and then how it's set up and how it scales internally is opaque to clients, opaque to the rest of the network, opaque to the cost structure. It's just an internal implementation detail of the validator. If you take this approach, then with the right blockchain architecture, like what we tried to do with Sui, like scaling out the throughput of the network and the storage and the processing capacity, it looks very much like a Web2 problem that the folks from the hyperscalers are familiar with. Like, okay, I have this database, like it's a bunch of petabytes now. It's going to be more later. Like, how do I make that bigger? Allocate more machines inside. And then the alternative approach is, okay, actually, like at the network layer, we're going to be aware of the like sharding as a concept that validators know about, that clients know about, that users are going to have to know about. And so when we want to allocate more capacity, like, we have to have a scheme for saying like, okay, here's who runs that new machine, and here's what part of the state it stores, and then here's what state should migrate over from existing things or other stuff. And then it just becomes a lot more tightly coupled to the design of the blockchain, and makes it sort of more complicated, because you're exposing those details and you can't just change them without breaking the protocol. And so our thinking about that has always been like, both of these approaches can work, but we think of like from the developer perspective, from the user perspective, what's the experience that you want? I think the experience that you want is like the whole state is just there. I can write code that can touch any part of the state, and there's no barriers, and there's no atomic swaps or like cross-chain movement or like bridging or any of that stuff. Just everything I want is right there at my fingertips. Like, this is like Web3 in a nutshell, like putting all the valuable state in one place. Or it's that every time I'd like to do that, I have to move from one to the other, or I have to write the cross-chain swap, or I have to use some library that deals with this. And so I think usually, I don't think anyone like sort of thinks that the experience of having to go across these barriers is better. I think it's just more of a question of like, do you actually think you can get the first approach to scale? And if you don't think that, like maybe you have to acknowledge like, okay, we'll give up on the ideal experience and sort of compromise and like do this thing that we think is going to work better. And so for us, like, we don't think that we have to compromise, and so we've taken the first approach. But I think there are many interesting designs along those lines.
And why, I guess, Sui is kind of unique, one of the few blockchains that have really taken this approach. Do you think other blockchains did not have kind of the learning lessons that Sui ultimately has came upon to build everything together and scale with additional compute that programmers do not have to program against it instead of kind of the more traditional sharding method? Why do you feel like earlier blockchains have taken that design where it seems, at least to me, fairly obvious this is a better design if you can do it?
Well, I mean, it's an interesting question. I mean, if you asked me to speculate, I think my answer would be that it was really about focusing about backward compatibility with the first standards in the space. Ethereum and the EVM. This is something that has a great developer community around it. This is something that has great use cases built on top of it. And but once you have those design constraints in place and you have billions of dollars in assets in there, then it's very hard to move forward in a way that fundamentally changes the design while also preserving compatibility with all that stuff, or doesn't shake things up too much. So I think it's more due to a status quo bias, which is very reasonable. Like, it's very hard to bootstrap an ecosystem from scratch, a developer ecosystem. It's hard to bootstrap an asset base. It's hard to bootstrap apps. And so it's sort of like I think it really comes down to this values question of like, is the what's valuable, what's already there, and we can sort of accept the technical limitations of that in order to preserve 100% compatibility with it, or like, are we willing to take the plunge and just do something completely from scratch? So I think it's more that than like a technical thinking, or like wondering which approach is better. But this is highly speculative. It's really hard to know. For us, coming from a tech perspective, or like a lot of the Mysten founders coming from a research background, we're always motivated by like, how do I do the right thing from scratch? And so that's the angle we took.
And I very much appreciate that approach. It's refreshing when a lot of people kind of look to their early entrants and say like nothing can be approved on that. And so I really appreciate kind of the radical new design, because I think that's honestly how we get the industry to scale. But maybe jumping back to Move, you've thought a lot about Move, kind of Sui shipped with Move. And I think it truly is a much better programming experience. I think Rust and some of these earlier languages, whether it's Solidity, are a little bit more open per se, but with Move, I would say as much as possible tries to eliminate the developer errors in a very programmer friendly environment. And so I truly would not be surprised if Move became the dominant programming languages within Web3 in a couple of years time frame. Could you possibly expand upon some of the things that either have been updated in Move or progress since you've really launched?
Yeah, absolutely. And I appreciate you outlining the goal of becoming the dominant language in Web3, because that's really what we're going for. But yeah, I'm the creator of Move. I've been working on the language since 2018, and I think the language has come a really long way in terms of its beginnings in DM and compared to where it is today. So the way we start off with DM is it was supposed to be this global payment system, but also it was focused a lot on compliance. So it was focused a lot on putting walls in the way on certain actions, in transferring, I think in a fully open smart contract platform, you want transferring to be really easy. But in a compliant payment system, only certain people can receive certain types of assets. Account creation has to be privileged. There are certain guardrails that got built in. So a lot of the changes we've made to Move are sort of going beyond the original requirements of DM and thinking about how does this work in an open system? So to anchor, and I said this again, but I'll say it once more because I think it's like a useful thing to anchor on. Like what we think of is smart contracts are the task of a smart contract is to transfer and share assets between transfer and share objects between. Sorry, I'll start with a good one so it'll work for the recording. We think the task of a smart contract platform is to enable transfer and sharing objects between agents. So like, let's break it down and really talk about like each of those. Like that's the vocabulary of what smart contract programs are supposed to be doing. So you better have really good abstractions and really good answers for all of those things. So for the transferring part in the original move, like you have to, for each new type that you declare, you have to sort of hand roll the transferring program. It's not something you get for free. And so like in the experience of building Sui, we're like, okay, we want so-called polymorphic transfer. Let's make it so all objects are transferable. So that's great. Like, developers are no longer having to hand roll that. And then if you want to put restrictions on a transfer, there's a special way to do that. But by default, like everything is just freely transferable. Then there's the sharing part where in Sui, like objects have owners. And this is also a change that we made where like in the original conception of Move, like there's no notion of an object or having an owner. There's just sort of types, and like the logic you write sort of defines what ownership means. And when we think about it, we're like, actually, there are like these very clear modes of different objects in the sort of smart contract world. It's either like it's an asset that it's in my address and it belongs to me, and like other people shouldn't be able to touch it in any way, or it's shared, like it's a DEX, it's an auction, it's a game that multiple people can play. And so just by having those different modes where it's single owner, no one else can touch it, like it's just inherently secure, you can't get things wrong, or it's shared and you have to say like who's allowed to do what operations on it, that really helps partition the space of things you want to do with smart contracts. So I think these conceptual, and so sharing also is a fundamental operation in Move as we have it now. Like you take an object and you can share it, and then that means like anyone can call its function, so they better have access control. Whereas when it's transferred, it's owned by something, and so it can only be sent in a transaction that's touched by its owner. This also led us to develop this thing that we've called programmable transaction blocks. And so there's this big problem in smart contracts of like, how do you compose existing code? Like I have function A and function B, maybe they're not aware of each other, and now I'm a user and I want to like atomically in one transaction, like call function A, get an asset from it and pass it to function B. And so originally in Move, we did this with scripts. And so scripts is like, okay, you have a main and it calls function A, gets the thing and passes it to function B. That doesn't sound so bad, but then like you think about the actual like client or front end experience of doing that, like is your TypeScript code going to write Move source code for the script and then invoke the compiler and then put the result into a transaction? It's like, that sounds kind of scary. Like most of the time when you're writing new code, like you're going to have it audited. Like, you don't want to call a compiler from the front end, all these sorts of issues. And so the workaround is basically like every time you want to compose two things, you have to either do a script that you build on the front end or publish new smart contract code that's doing that composition. And you really don't want that. Like, in a lot of cases, you have this sort of ad hoc composition where someone's deciding very much on the fly, like, I want to do these two things together. Like we see this often in DeFi with like routers that like, oh, I'm going to decide what pools I'm going to hit at the last second based on what the current price information is. And I don't know in advance what it's going to be. I want to do that on the front end. So this programmable transaction block feature helps a lot with that, where the way it works is basically in Sui, you don't send a transaction, you send a programmable transaction block where there's a first, it has a set of inputs, you call a function, that function has outputs, then subsequent function calls can take as inputs both the output of previous function calls and the initial inputs. And so it's sort of like the set of Lego blocks that you snap, nicely typed Lego blocks that you snap together and can accomplish these complex things. And so you can finally accomplish this task of, I have these two things that don't know about each other. Neither author meant for them to compose, but I as a user can do that and like build these things in the front end in a way that does it. So I think that was like a huge step forward for us. And we see in Sui, like the number of transactions within a single programmable transaction block is growing all the time as users figure out like, hey, I can do more work in a single transaction. I can do more atomic operations. I can do more complex stuff. It's quite cool compared to like sign, send, and like losing that atomicity. So I think, sorry, go ahead.
Can you maybe provide an example for some of the non-technical people, like what type of transactions that ultimately enables?
Yeah, so the one example I like to use is something like, say I'm playing a game. It's a don't get in copyright trouble, but it's a Nintendo game that has like a Mario in it. And then I'm going to play this game and I'm going to win a trophy. And then when I win a trophy, I'm in a sort of game player, like hacker collective, and I want to like put it in my shared trophy case. Now, like from a smart contract perspective, like the game doesn't want to know about your doesn't want to know about your trophy collective. Like that's sort of a thing where the trophies from lots of games come from, and then also like the trophy thing doesn't know about the game. It's like, hey, people can put these everywhere. So there's not a logical place to like publish the function that says go and do this. And so the way you do that with a programmable transaction block is you call the first function, that's like play game, it does its thing. It returns the trophy, which is an object. And then that object is just, free to be passed into whatever function the user wants. And that next function is determined by the next move function that you put in the programmable transaction block. So you would call like play game that returns a trophy. And then you would call publish trophy or like, add trophy or whatever. And then the next function takes the trophy's input and then, touches the shared trophy case objects and puts it in there. That's a very simple one that just consists of two. But then a lot of times you end up wanting to do many such actions. It also lets you do basic things like I want to do a batch of like 200 payments. And rather than implementing special logic for batch payments in the smart contract, I just do 200, single payments, and it makes it much easier. So those are basically the types of things where it's like, I have this nice paradigm of objects flow in, like I call it a function, objects flow out of it, and then the client gets to decide what to do with them next. And the original programmer doesn't have to worry about all the possible different things someone might want to do with their objects.
And is this uniquely enabled by Move or the object-oriented programming that Sui enables, or a combination of the both?
So this is uniquely enabled by Move, the typed object output parts, at least. If you're familiar with Solana and the paradigm where it's like you have a transaction and then you have instructions, definitely like that enables some flavors of composition. Like definitely you can do batches of multiple instructions. But I think a problem people have a lot is like, what did the previous instruction do? And like, how do I make sure that the next instruction is like using that thing and not using something else? So I think like it's spiritually similar to that, but really this paradigm of having explicit input and output objects and then having them be typed so that they snap together just so, or that they don't at all.
Okay, makes sense. Interesting. Very cool.
Yeah, so this is sort of like along the lines of answering a question about what's going on in Move. So I think those are like the fundamental sort of like platform features that have changed in Move since the DM days. But then we're starting now to make a lot of improvements at the source language and tooling level as well. So a very long request that a very long-term request that we're finally getting around to is we're going to have enums in Move. So that's great. Like that helps a lot with type evolution, where it's like you have in the first version of your contract you have a type with certain fields. Now you want to add a field or do some other things. Now you can add that easily. We're also having method style syntax or receiver style syntax, where right now you have to have the module name and then a colon before calling any functions. That ends up making your code a lot longer. Now you can just say, you would say, vector : pushback. Now you can say v dot pushback if v is a vector type, and then you're done. So that part is great. And then also better macros for letting you do things like complex looping and iteration, or just code reuse that you can't do with a simple functional rewriting. And the one other feature I forgot to mention, this is more of a fundamental platform one than a smaller new language feature, is this dynamic fields thing. So the way we think of this is that when you declare a struct type, it has like an F field that's U64 and a G field that's a U64, whatever you want. That's the static type of your object. But then it might be the case that you want to add some things on demand or add or remove them on demand, sort of, JavaScript like, where it's like, I have a hero and I want to add shoes or a boot to him, like we talked about later. You don't want to implement that by having a bunch of fields that are like option of shoe, option of boot, option of like every possible type that this thing might have. It's a lot more mix and match, or like, happens after the fact than that. And so the way we implement that is that every object has an implicit hash table inside of it that you can stuff other objects into. And so this is the thing that we call that implicit hash table a dynamic field, because the hash table can be keyed by whatever, and then you can put things in there or take things out. And so this is how we implement big collections like hash tables or sets. But then it's also this really flexible feature with objects where you can sort of like dynamically add and remove other objects or like other data to them. So I think that's the other big fundamental change that we've made since the early days.
Maybe a higher level question, Sam. I think in terms of kind of general adoption, people started with like Solidity or EVM, and then now have been experimenting, say, with SVM. In your terms, or like, what do you think all these like features I think are necessary and we need these to scale? What is that like in your mind first step that we need people to explore the Sui ecosystem? Do you think kind of after listening to this podcast, like developers will be like, yes, I need this, and just jump into the Sui ecosystem to try? I'm curious, like in your mind, the engineering mind, what would get you excited to try Sui, or what do people not understand about Sui that they should try it?
Yeah, so I think there are a lot of answers to this, and sort of depends on what you're looking for as a builder. But if I had to say one thing, and I think this is something we're seeing now, is the ZK login feature. Like we've seen an explosion in developer interest since we announced that, where it's like, hey, you want to provide this polished experience for your app. You want to have SSO like login. Guess what? Like that's a native feature. Just like call this prover API. Copy this example code, and like you're off to the races. And now that you've got that problem solved, like what do you want to build? And you don't just have to build this for the 10 million, 30 million nerds with wallets. Like you can build this for anybody. And then that's sort of like the real where you get in. It's like, also I don't have to write this scary language. Like this looks a lot like something I'm used to, or like, okay, there's these nice objects with types. It looks a little bit like Rust. It looks a little bit like JavaScript. When I get something wrong, I get a slap on the wrist from the compiler. So I think that's a huge entry for now. I mean, certainly we've had a lot of folks where they're curious about Move and they're tech forward and they want to try another smart contract language. But I think like that's the most powerful lever, especially for developers outside of the conventional Web3 space that we have right now.
Yeah, it makes a lot of sense. I mean, I think as much complexity that you can handle within the protocol that abstracts these key friction points and making those more frictionless on the developer side so that they can focus on being product engineers instead of protocol engineers is a major step forward.
100%. Yeah, I
It's
think if you have to be a protocol engineer to build something, like the security posters is never going to work. And I think that's one of the big problems with these existing smart contract languages is like, even though the folks who build things are so hardcore, like so security conscious and know so many details about the protocols, it's still not possible to write safe code. And that's not because they're bad devs. They're great devs. They're like the best the space is possibly going to hope for. But you really need the sort of safe by default language, and you need those abstractions that hide the details and without getting you into security trouble, or you're just not going to grow the developer population much beyond what it currently is.
100%. I'm rooting for Move because I think it will be much better for the entire industry. So really appreciate what you've done there to create it. I truly think it's a big step forward.
Lots of work to do, but yeah, we're happy with where it is, and it seems to be working out so far.
One thing that I think that you've been working on behind the scenes, as well as some improvements on consensus. I think this has been a fascinating field where people go off and do a bunch of research and then bring it back into production, whether that's increasing throughput or reducing latency. I know the Mysten Labs team has been putting a lot of effort into this field as well. Can you talk about some of the advancements that the Mysten Labs team has made in the consensus since we talked about a year ago?
Absolutely. I'm really excited to talk about this. And I think I gave the same caveat last time, but I'll give it again. Like this side is not my area of expertise. George, our chief scientist, and the researchers and some of the engineering folks are really the brilliant minds here, but I'll try to summarize their work at a high level and definitely have one of them on if you want to go like really, really like consensus nerd deep. But at a high level, like, we have this new effort that's called Mysticeti. And so there's a research paper out that we can link. And the thing that Mysticeti is doing is if you look at Sui and the way it is today, it's sort of this merge of two different protocols. So one of the protocols is FastPay, or what was originally called FastPay. And that was trying to solve the problem of, okay, I want to do really, really low latency transactions and highly scalable transactions, but I'm willing to restrict the amount of programmability that I get to the subset of computations that don't require full consensus. So, object transfers, NFT mints, token transfers, this sort of thing. And so that's one part.
Non-contentious pieces of state.
Exactly. Things that don't require shared state. Things that don't require shared state is exactly the set of computations. This thing ends up being a lot broader than you think. I think we've seen that with Sui, but that's one part of it. And so we have that today. We call this the consensus fast path. You get 400 millisecond end-to-end latency if you use it. It's great. And then the other part is okay, we're going to have shared state, obviously. This is a blockchain. Like, there's going to be trades on dexes, there'll be auctions, et cetera, et cetera. And so it's like, how do you? And so for that, we had the work that the team has done on Narwhal. And so in the original Sui, it's like, all right, let's smush these things together, but they're two separate protocols, or figure out how to make them interact. But the way in which we did that, sort of like gluing them together, sorry, to say more explicitly, like the Sui protocol views Narwhal as a black box, but if you open up the black box of Narwhal, there's a lot of things that look like what you're doing in FastPay. Like, FastPay is built around this primitive called consistent broadcast, where it's about send a bunch of stuff to folks, get an attestation, and make sure they're all on the same page. There's a consistent broadcast step both in FastPay and inside of Narwhal once you get in there. But if you don't open up a Narwhal black box, you don't see that there are these two different steps that can maybe be combined. So what Mysticeti is trying to do at a really high level is like, okay, given that we want two different parts, like we want a consensus engine, and then we want this fast path for certain computation types. How can we merge the consistent broadcast step and sort of make these things fit together as nicely as possible? So that's really what this long-term effort has been doing. And a lot of the ways we had glued these together before meant that you got worse latency than what was theoretically possible for the full consensus case. But now, like, we can get much, much better results. So, to put concrete numbers behind it, like, we get about 400, 500 milliseconds end-to-end latency for the single owner object transactions today, and about 2 for shared object transactions. And after Mysticeti, we think we can get about 0.25 for the single owner and about 1 for the shared. So big increase in latency here, all while maintaining the throughput we have, or actually like getting more throughput with fewer resources. So it's a research prototype, but we're pretty excited about trying to take it to production in the next couple of months.
That's awesome. Very impressive. So, and maybe just to reiterate, today there's 2 consensus algorithms, one for, I say non-contentious pieces of state, where you have the fast path, where you can skip the ordering step. And then for the contentious pieces of state, you have to have that ordering step. And this new algorithm, or consensus algorithm, is that combining these 2 individual consensus algorithms into one, or is it still separate? They're just both more optimized.
So it's still separate, but I think we thought of it, like, before we thought of it as, okay, we have these very separate things, like there's FastPay and then there's Narwhal. And then in the new conception by the research team, it's like, how do we have a consensus algorithm with a fast path? And when you co-design these things and let them use some of the same components and primitives, then you can really get a lot of efficiency gains, is the core of it.
Interesting. And is this still a DAG architecture?
Yes, absolutely.
Okay. Interesting. And you said potentially be on mainnet, say 6 months.
So I don't want to make any promises on that, because with this thing, it's like, you've done the work, but the most important feature of the network is its stability and its security. So we're not going to rush this if there are any risks put forward. So I think what we're going to do is, like, the team is working on a plan to incrementally add various bits of this, and then we'll see when the whole thing gets into production. And so I think 6 months is like definitely not a promise. That's a reasonable timescale for exploring this, but ultimately, like, for any of these tough transitions, you really got to let the security and reliability determine how soon something gets in.
True. I think we've seen Solana kind of shoot itself in the foot a couple times with trying to rush something. So slow and steady, I think, wins the race.
Oh, totally. I mean, I think if you look at the merge, that took a very long time, but the rollout was extremely seamless. And so I think if you can get the stability part of, and like care taken in that process, while maybe being on a faster time frame, that could be the best of both worlds.
Fully agree. One thing that ultimately got flagged with me, I was talking with Emin, the founder of Avalanche, and we were talking about DAGs versus kind of traditional leader-based protocols, was around kind of like channel saturation and potentially having 2 leaders ultimately communicate kind of maximal channel capacity at the same time. Have you seen that, or do you ever anticipate channel interference by having 2 leaders simultaneously saturating the data, ultimately dropping, say, from like 2 gigabytes of channel, 2 leaders simultaneously communicating 2 gigabytes or 1 gigabyte each, but the channel capacity is only 1 gigabyte, if that makes sense?
Yes, this is a disappointing answer, but I think this is below my level of abstraction on our
No worries.
consensus and networking layer. George would be a fantastic person to go deep on this one. But
And I would love to have him on as well, because this is one thing that I've been trying to kind of figure out, and people have been kind of flagging with me, but been nerding out on trying to learn more on consensus algorithms. But no, it sounds fascinating. I think being able to get latency down that low in a global network, you're saying a couple hundred milliseconds, and then kind of for full ordering around a second, is extremely impressive.
yeah, yeah, we're really, I think, starting to push up against the theoretical limits. Whereas like before, we had the theoretical limits in the protocol, but we weren't approaching them in practice. And I think now we can really have both. So yeah, the with the caveat that we got to be cautious in rolling it out. I'm really excited to see this go.
For sure. Are there anything, I would say, learning lessons since you've launched approximately 6 months ago, a little over 6 months ago, to today, and just seeing how the network actually performs on mainnet? Or has kind of the testing and testnet really been like that core building block that nothing really surprised you?
Yeah, it's a great question. I mean, so certainly we in coming up to launch, like I think we focus, like as one does, like a lot on the right path and the performance of the right path and the stability of ensuring that all of that stuff works. But then of course, from the app perspective, like it's great if you send a transaction, it happens very quickly. But if that information doesn't get propagated quickly enough to full nodes, or like if there's stability issues there, or if like indexers lag behind, then it doesn't matter if all of these things are happening very quickly. So I think we underestimated. Well, obviously we knew that was important, but that you really have a lot more control in the right path because it's all within the realm of the validator software, which the core team works on. And we have great monitoring and analytics. Whereas like in the read path, it could be any full node anywhere in the entire ecosystem that could be configured this way or that way, or be on this machine or that machine, and could be having these problems. And so I think like it's at the beginning we had some rockiness in terms of just making sure that that part was like as streamlined and as efficient and as easy to use as the other stuff. I think we're in a very good state there now, and with this big RPC 2.0 migration that we're making, things will be even better. But I think that's one thing where it's like obvious in retrospect, and if the core isn't stable or if the right path isn't working well, then it doesn't matter if the reads work well or not. But I think we're definitely, in the way we approach core engineering now, we have a lot more of a balance in terms of thinking about both sides of the equation rather than just focusing on the fun part, if you will.
The reads, I mean, it's one thing to optimize the writes, but you have to do the reads as well. That can be challenging, especially when you get up to the number of transactions that Sui is trying to propagate.
Totally.
And
And a pet peeve of mine in this space with this is like people use this like time to finality metric, but then like finality is not something that's observable by a client. Like this is a theoretical thing that happens like inside of a validator, and no one actually knows. But like to a builder, time to finality doesn't really matter. It's like if it's high, the end-to-end latency isn't going to be higher. But like what you really care about as a builder is the end-to-end latency. So you got to be talking about that number too, and like optimizing those bits rather than just the finality bit. So I think we already had that mindset, but it's really hard to carry that all the way through.
I really wish we could kind of unified standards across the industry. I've been trying to do a little bit, but anytime you try to make a standard, people yell at you, so it's not very easy.
Yeah, especially when people just want their low numbers, which is fair. We want to talk about how fast our protocols are, but yeah, we also need to talk about the numbers that make sense for builders. So it's a tough effort.
I think in the last podcast, I also asked you, in terms of scaling, or one of the things that you thought was going to be the most difficult in kind of reaching mass adoption, whether that was going to be different things on the consensus design, different things with the virtual machine, either the high throughput and the bandwidth requirements there, or ultimately storage. I believe you said storage. Would you kind of uh, is that still kind of, you think, the end state or the hardest thing to scale in these blockchains? Or if not, how has your kind of view changed?
Yeah, so I'm trying to remember back to what I said. So for us, that hasn't been a significant challenge, and I think we don't expect it to be one going forward. It's more of a, let's call it a conventional engineering problem or Web 2 engineering problem than many other parts of the stack. If I had to guess what I was saying then, or think about like why this is challenging elsewhere, is I think the storage paradigm used in a lot of other chains is really based on like, okay, I have an account based system, I have a Merkle tree of accounts, And basically, like the way I do authenticated reads is that there's some accounts at the leaves, there's a transaction, it changes some of the accounts, and then I have to bubble that up all the way back up to a Merkle root. And I basically can't authenticate anything for you until I've got a new Merkle root. And then basically, like, folks will place that process on the critical path of execution, and then basically like, okay, now your entire execution is bottlenecked on computing that new Merkle root. And so I think folks have gotten wise to that. And a lot of times, like if that structure exists, it's moved outside. But even when that's moved outside, like this sort of thing is somewhat hard to scale. Like it's usually like an efficient Merkle tree computation. Like you fit the whole thing in memory, and that's why you can do it quickly. But all of a sudden, like you want to have a Merkle tree that's distributed across multiple machines. Like now, maybe like every production of an artifact that requires authenticated reads is a distributed algorithm. Okay, this starts to be quite tricky because you have to scale that in addition to scaling the execution. And so with us, like we've set up the storage in a way that we don't need a global Merkle tree to serve authenticated reads, and so we don't have that sort of bottleneck of propagating up and computing a new state root. So I think if you're going with that architecture, which it's the way ETH started, so a lot of folks are reasonably doing it that way, then I think it becomes very hard to scale storage. But for us, it's just more like, well, allocate a new RocksDB instance and decide like, which object IDs belong in this one and which object IDs belong in the existing one. It's a much easier problem.
So is the answer still storage?
for us or for the space?
I would say particularly Mysten.
Yeah, for us particularly. I mean, I think for us, and even though I just finished speaking about how much we're going to improve on latency, I still think just turning the crank as much as possible there, and really like getting to the theoretical limits in terms of the protocol design, but then also doing the engineering to make sure you're right on those limits or as close as possible is really going to be the thing. Just because I think like it's really, really hard to have a low latency. It's really, really hard to have low latency transactions in a globally distributed network with hundreds or thousands of validators. And I think like every millisecond of latency that you can shave off, like maybe enables some new use case. Like there are certain trading strategies that work under certain latencies and not others. If you have latency that's too high, like there are some games like consumer experiences that are going to be less smooth or just won't work at all. And so I really think like that's the problem that's never going to go away, and that you always get wins by getting better latency because you enable more use cases and smoother experiences. And it's really, really hard to get it and to keep it consistently because it's both a theoretical and an engineering problem. So I think if I had to say one thing, I would probably say that. And, there's so much talk in the space about TPS and throughput, which is clearly very, very important and like something that we've been very focused on at the beginning. But I think like latency is the thing that affects every user every time they send a transaction that everyone touches and feels every day. Whereas the other thing is something that happens on the edge case of your system that you obviously have to be prepared for, but is more of an out there concern.
True. And it's kind of fascinating to me. I mean, going back to when I was in product, how much time and engineering effort would be used towards trying to shave off 100 milliseconds from a checkout experience, and the bounce rate if that latency was high. And people in Web3 are not fine, but seemingly okay with multiple second latency, at least initially. I don't think that is going to be really scaled to mainstream adoption.
No, it's a hard problem. It just really, like so many of these other things, like requiring to install a wallet, like needing to go and get the native currency beforehand, it just limits what you can do. Like you can still do a lot within that closed off garden, but let's open it up and see what else we can do.
Very true. In terms of maybe kind of wrapping it back up, and like as we end the podcast, I think there's a lot of different people that are interested in the Sui ecosystem, whether that's the builders or myself kind of on the VC side, or other people in the venture capital space looking to either learn more or have that initial spark in the community or application to jump into the Sui ecosystem and really take a hard look. I know you kind of touched upon ZK login, and I think honestly it's an amazing feature that is absolutely needed. But is there anything else that you would say look into or you're uniquely excited about in the Sui ecosystem since you've launched?
Yeah, so I would say a great way to get an overview of the Sui ecosystem or some things that are going on is like jump into quests. Like, there are these quests that run that highlight projects that are prominent projects that are going on the Sui ecosystem and have different themes. So it's a great way of sort of getting hands on of like, okay, what have folks actually built? What are the different experiences that are available? How do they compare? Sometimes there's a fun aspect of contests or gamification to it. So that's a nice way to get familiar with some of the top projects and sort of get the experience of like what it was like for a consumer or a user. And then from the tech focus lens, yeah, I think ZK login is great to look at. Of course, like to take a look at Move if you haven't in a while. Um, I think in addition to that, like we have really strong like the builder groups and like we're working on like technical communication and blog posts. So, like there's this Suinami writers group that's really great for like that our builders hang out in, and also a Discord that's very active. I think that too. Like if I want to know what's going on in an ecosystem, like there's like the consumer angle, and then you want to know like what are builders talking about and what's coming next. So I also the Sui developer forum. So I would try to hang out in as many of those places as possible to see what's coming down the pipe.
I see you're very active there, which is very cool.
I try, I think there's nothing more important for me to be doing than to like encouraging builders, unblocking them and helping them see what's possible. And, of course I have to scale myself in doing that. And we have there are great teams both on the Sui Foundation side and the Mysten side working on that. But, I still really enjoy talking to builders whenever I can.
I think that's honestly the alpha within all Web3 is just following the builders and kind of these new 0 to 1 primitives where you have something that was not possible before. And I would definitely say Sui and Move are both in that category. And that's why I'm so excited about both, is because I truly think it unlocks scalability and new types of applications that just weren't previously possible on kind of like the first entrance of blockchain architecture. So yeah, thank you for building Mysten, building Sui, and what you've been doing with Move, because I truly think it's going to unlock some new stuff.
Thank you for the kind words. I mean, I love that framework. Like if you have a primitive that's unlocking something fundamentally new and you have strong builders, like that's exactly where exciting stuff is going to happen. And we think Sui is a great spot for that. But I think like if you follow that around the Web3 space, like you're going to be right on the bleeding edge, and you're not going to miss anything interesting.
100%. Well, Sam, I really appreciate you coming on the podcast again, sharing all the updates that you've really been putting blood, sweat, and tears, and also the Mysten Labs team into making sure Sui unlocks those primitives and can scale when the time is right. And I think you guys are very much on that trajectory, highlighting that even with doing the most transactions per second out of all blockchains. So again, thank you so much, and appreciate all the words of wisdom.
Thanks a lot, Logan. Thanks for having me. It was a pleasure for me to be on, and I really appreciate what you're doing for the space. Love the podcast.
Thank you. Appreciate it.